dear student, this is KOUSHIK. Today we will discuss the concept that is the most important concept, that is function. So why we studied this concept? You were studied this concept in class 11, but in this class 12, the generalization of this concept is types of function. For that you must have the basic knowledge, that is what do you mean by a function. So that's why here is the class about the function. So let's start with the definition. So definition of function. So what do you mean by a function? A function is a special type of relation. A function is a relation. In fact, special type of relation. Say F. A relation F from a non-empty set A to a non-empty set B. A relation F from a non-empty set A to a non-empty set B is said to be function. Said to be a function if, what is the condition? If every element of the set A, has one and only one image. In the set B. Then we say that relation is a function. So function is a relation denoted by F, is a mapping from A to B, is said to be a function if every element of the set A has one and only one image. One and only one means unique image in the set B. So that relation is called function. So, to better understand, I am using the arrow diagram. Here the set A to the set B, I am taking 1, 2, 3, 4. For B, I am taking A, B, C, D. That is, the set A is non-empty. It includes 1, 2, 3, 4. And the set B is equal to A, B, C and D. Okay. So here is the relation. So if 1 is related to A and 2 is related to B, 3 is related to D and 4 is related to C. So 1 is related to A, 2 is related to B, 3 is related to D and 4 is related to C. So we say that 1 is related to A. Means every element of A is what? 1, 2, 3, 4. Every element of the set A has one and only one image. The image of 1 is what? A. Here this represents element and this represents images for these elements. 2, the image of 2 is B and 3 is 3. The image of 3 is D and for 4, the image of 4 is C. Is it okay? So it has one and only one image. 1 has only one image, namely A. 2 has one and only one image, namely B. 3 also has D and 4 also has one and only one image, that is C. Is it okay? So therefore this relation is clearly a function. Now I am taking another same set 1, 2, 3, 4, A, B, C, D. Here 1 with A, 2 also with A, 3 with D, 4 also with D. It means if I take 1, the image of 1 is A. That is, image of 1. Image of 1 is A. Okay. If I take 2, what is the image of 2? Image of 2 is also A. 3. For 3, image of 3 is what? D. Next, if I take 4, image of 4 is what? Is D. So clearly the every element of the set has one and only one image, namely 1 has only one image A, and 2 has one and only one image say A, and 3 has D, 4 has one and only one image, namely D. Therefore it is also a function. Okay. Now I am taking for an example which is not a function. If I take 4 not related to any number in the set, is it a function? Which is not a function. Why? To be a function, every element of the set, here 4, so which is also an element of the set, but do not have any image in the set B. Is it right? So every means it must, all the elements must contain at least one, that is at least one, not at all. It has unique image in the set B. So therefore here 4 does not have any image, therefore which is not a function. If I take say 1, 2, 3, 4 and A, B, C, D. If I take 1 related to A, 1 related to B, 2, C, 3, D and 4 with B. So what is the image of 1? Image of 1. What? Image of 1 is A. Not only one image. 1 has two images, namely A and B. Image of 2 is what? C. Image of 3 is D. And image of 4 is B. 2, 3, 4 has one and only one image. But image of 1 is A and B. The element of the set A has namely two images, namely A and B, therefore which do not form a function. So let us understand notation for this function. Next, notation. So if we have a function f from the set A to B, it is denoted by f is a mapping from the set A to the set B. If I have f of A is equal to B or f of x is equal to y, then we say that B is image of A. We say that B is image of A under f, under the function f, and A is called preimage. Preimage of what? B under f. So that is, here the small b is called image of what? The element A under f. If I take A is called what? A becomes a pre-image for what? B under the same function f. Y, I am just changing in place of A x, in place of B y. Here y becomes what? Image of the element x under f. And x becomes pre-image of y under the function f. If I have a function say g from set x to y such that g of s is equal to t. What it means? So there is a function g from a non-empty set x to a non-empty set y such that g of s is equal to t. It means t becomes an image of s. Here t is image of what? The element s. And s is called pre-image. S is called pre-image of t. Under what? What is the function here? Under the function g. Is it okay? So this is the notation. If I have the same function say from A to B, say f is a mapping from 1 to A, 2 to B, 3 to D and 4 to C. So now it is clearly a function 1, that is image of 1. Image of 1 is what? A. Image of 1 is A. It means it is denoted by image of 1, that is f of 1 is means equal to A. Is it okay? So image of 1 is A. Now take 2. What is the image of 2? Image of 2 is B. So that is, it is denoted by image of 2. F of 2 is what? B. F of 2 is equal to B. So that is 1 maps to A, means here A is F of 1. 2 maps to B under F. It means B is the image of 2, that is F of 2. Now what is C? C is the image for what? 4, that is F of 4. Now what is D? Which is the image for 3, that is F of 3. So this is the notation for image. Now for preimage. Now I am taking preimage. A has preimage, namely 1, that is F inverse. If I take from left to right, it becomes image. If I take from here, right to left, then it becomes image. If I take from left to right, then it becomes preimage. Okay. So now F inverse of, so A has preimage, namely 1. So that is 1 is equal to what? F inverse of A. So that is preimage of A is 1. Is it okay? Next, F inverse of what is 2? 2 is equal to F inverse of B. That is preimage of B is 2. Next, F inverse of 3. Sorry, F inverse of D is equal to 3. Next, 4. For 4, what is the image? C. So preimage is F inverse of C. Is it clear? So that is, if I take, say 1, 2, 3, 4, 5, and here A, B, C, D, E. So 1 maps to A, 2 maps to B, 3 maps to C, 4 maps to D, 5 maps to E. It means A is equal to F of 1. Image of 1 is A. Image of 2 is B. Image of 3 is C. Next, image of 4 is D. Next, image of 5 is E. That is F of 1 is A, F of 2 is B, F of 3 is C. F of 3 means what? Image of 3. F of 4 is what? Image of 4. Okay. So now, taking preimage. So what is 1 for 1? Preimage of A. Preimage of A is 1. Preimage of B is 2. Preimage of C is 3. Preimage of D is 4. Preimage of E is 5. That is preimage of, what is that? B is 2. If preimage, this refers to preimage notation. F of refers to image. F inverse of refers to preimage. Okay. So F inverse of what? C is 3. F inverse of D is 4. Next, F inverse of E is 5. So I am taking here, say 4 examples. From A to B, from X to Y, from P to Q, from S to T. So here is the, say, function F. I am taking G. Here I am taking from P to Q has H. Here I am taking, say, T. Okay. Small notation, small letter denotes function, capital letters denote set. Here F is a mapping from. So here I am taking 1, 5, 6, 3. Randomly I am taking. Here I am taking, say, 10, 15, 20. So if the mapping is like this, 1 maps to, 5 maps to, and 6 maps to. So that is the function F. Now here I am taking same set, same 1, 5, 6, 3. Say 10, 15, 20. If I have 1, 6 maps to 20 and 3 also maps to 20. So now here I am taking 1, 5, 6, 3 and 10, 15, 20. So 1 maps to and 5 maps to same and 6 maps to 15 and 6 maps to 20. 3 also maps to 20. Now I am taking 1, 5, 6, 3, 10, 15, 20. So for that 3 maps to 10, 6 maps to 15, 6 maps to 10 and 5 maps to say 20. So let us check whether f, g, h, t are functions or not. So start with f. Every element is what is the definition of function? Every element of the first set has one and only one image in the second set. That is the definition of a function. Here 1 maps to 10, 5 maps to 15, 6 maps to 20. What about 3? 3 does not have any image in the second set B. Therefore, f is not a function. To be function, what is the definition? Every element, every. So that is important. Every element of the first set has image in the second set, say B. So therefore, which is not a function. Next, here I am taking G. 1, the image of 1 is 10, okay, 5 is 15, 6 is 20, 3 is 20. Clearly, all the elements of first set, say X, has one and only one image. 1 has only one image, 10. 5 has only one image, say 15. 6 also has one and only one image, 20. 3 also has one and only one image, namely 20. So therefore G is function. Now for H, let us check whether it is a function or not. Here 1 maps to 10. That is, image of 1 is 10, image of 5 is 10. Image of 6 is 15, image of 6 is 20. That is, the number or element in the set P has 6 has 2 images. Not one and only. It has 2 images. Namely, what are those? 15 and 20. So therefore, H is not a function. Is it okay? Now for T. Here, 1 does not maps to any of the element of the set T. Therefore, 1 do not have any image. So every element of the first set must have one and only one image. So therefore, here 1 do not have any image. In fact, here 6 also have 2 images, namely 6 maps to 10, 6 maps to 15. So this is the function T, which is not a, the relation T, which is not a function. Let us check whether it is a function or not by means of graphical method, that is vertical line test. Vertical line test. Okay. So what it means? If I have the graph in xy plane, so x-axis and y-axis, if I have the graph, say this is a graph. Okay. I am taking like this. So this is a graph of some function, say f. So which is a graph. If I draw a vertical line, it touches exactly at one point. If I draw a vertical line, it touches the curve at one point. If it touches at one point, then we say that that relation becomes a function. Is it okay? Then this curve becomes a function. If I take any vertical line, it touches at here I am taking like this, then it touches at one point. Okay. So now I am taking another graph, say like this, that is sine curve. If I take any vertical line, so this touches to one point. If I take any vertical line, then it touches to only one point. Here it does not touches this one. Here it touches to. Okay. So therefore this function is a, this relation is a, this curve is a function. Is it okay? If I take, say, parabola, this is x-axis. If I take a vertical line, then it touches to 2 points. So therefore, which is not a function. Okay. So this is not a function by vertical line test. Take circle. Okay. For this curve, if I draw vertical line, it touches exactly 2 points. Okay. So not vertical line test, it means the circle, not a function. Circle, not a function. Why? Because for every x value, it must have one and only one y value. That is, take x is say, this x is say 3. It must has one and only one value. For every value, it has one and only one image. Then only it becomes a, the relation or a curve becomes a function.